Let's try that again. Greetings. Welcome to welcome to Ask the Architects. This is like Click and Clack, the Tappet Brothers. Right. So I'm Mark. I'm chief architect for the Java Platform Group at Oracle.
I'm Brian, Java Language Architect.
And if you have any management questions, we have George Saab sitting here in the front, Senior Vice President of the Java Platform Group. Right, so it's Q&A. Back in the day, we used to use Twitter for the purpose of gathering questions. Unfortunately, Twitter has changed, so we won't be doing that. I think it's probably just maybe stand up and come forward and state your question. We don't have a mic for the audience, do we?
No, we repeat the questions for them.
We will repeat the questions.
And the best kind of questions are not the, how does this particular feature work? Because you can look that up. But the questions that generally generate the best discussion are the ones about why. Why do we do it this way? Why don't we do it that way? What are the trade-offs or the considerations? Because those are the things that we don't really get a chance to talk about at conferences as much. So it's open to you.
Yeah, but just so you know, if a question starts out as, "Excuse me, why don't you just?" then that will trigger Brian, and his head will explode.
I'm going to make fun of you if you do that. Which I enjoy, so it's not a problem.
That's okay. All right.
Why don't we just remove the null pointer? That's an excellent question. Because it would break all the Java code in the world. And we don't want to do that.
Why? Because we like our jobs?
But that doesn't mean that we can't do more to manage the risks associated with null pointers. The problem with nulls is not nulls. Nulls are fine. The problem with nulls is when you think you have something that's non-null, and it turns out to be null, and you're surprised because you treat it as if it were non-null, and then you get an unexpected null pointer exception. What a lot of other languages have done in this space is to extend the type system to support nullable and non-nullable types. And that's a totally sensible thing to do, and we're exploring that in the context of Project Valhalla. I'll talk about that more tomorrow. But our interpretation of that is necessarily going to be different from what Kotlin did with it, or what Scala did with it, or what the languages that actually invented this this convention did with it. And again, that's necessary because we don't want to break all the Java code in the world.
Just one thing is, might be management question, but I don't know. This is always what I'm confused about is, we have Graal and we have Hotspot. How do they go together at the end of the day? Are these really independent technologies versus Oracle here and Oracle there? This is more open, this is a little bit more closed, whatever. So what's the direction? What will we see in the future? Or maybe this stays two projects independent, developed independently, never see common ground? I don't know. We can postpone this to next year if you like.
I was going to say, ask us in a few years, and we'll tell you how it worked out.
That might be the best answer.
Okay.
So the question is, when you see a JEP, has it been through a lot of revisions internally? Yes, and many of the revisions aren't done internally. They're done in the open. And if you're really a glutton for punishment, you could watch every JEP issue in the JDK bug system and watch it evolve over time. No, we put a lot of effort into JEPs because they have turned out to be pretty much the primary channel that we use to communicate about new features to the broader developer ecosystem. Oddly enough, that wasn't originally the primary purpose of JEPs, but that's how they have come to be used, and so we're leveraging that. We're not going to try to change it because it actually works pretty well. Most people in the ecosystem seem to know that, oh, when a JEP pops out with a short number, then maybe it's time for me to start paying attention to it, and that's generally a good clue. But yeah, JEPs, depending on it, there's a lot of variance, of course. Some JEPs are quite short and easy to write. Remove the x86 32-bit port. Okay, I mean, how long can it be? On the other hand, there are JEPs such as, for example, JEP 401, which will be the first Valhalla JEP. Those of you who follow JEPs know that 401 is that's a number a bit in the past at this point. So, and this is a reflection, not a bad reflection, Brian, but it's a reflection of the long path that the Valhalla project has taken. That got a JEP number. It became a candidate at a time when, okay, we kind of thought in Valhalla we sort of know what we're doing, and okay, here's the first JEP. Let's get it to candidate state so we can move it along and get that into a release. Well, it turned out that was not the best. The design at that point was not the best. It was, as Brian has said in other venues, the peak of complexity. Thankfully, we have descended down the mountain. It is things are looking much better now. So that JEP, even though it's been candidate, has evolved a lot. But even before it was candidate, it evolved a lot. We put lots and lots of hours. A lot of thanks are due, in fact, to Alex Buckley in the Java team, who does a lot spends a lot of time working with people to get JEP text into shape. And then, of course, when they come to me, I review them and sometimes do partial or full rewrites. But no, it's an important channel. So I'm glad to hear people are paying attention to it.
And if you're working on a JEP, you have a lot of choices about when to publicize it. And obviously, like in the early phases of the cycle, you want to do something vaguely in this area, but you're not sure what. And then there's a design activity where what you intend to do becomes more concrete, but it still may have to be validated by implementation and use. And so it may evolve further. And one of the things that we found was that if a JEP was vague because we didn't know what we were going to do, it sowed more confusion than enlightenment. And so, one of the things that that you'll see in the organized projects in OpenJDK, like Valhalla and Panama, is there will be a lot of things that look like formal write-ups of something, but they're not JEPs, right? So whoever is leading the project may say, "Here are my collected thoughts on X, Y, Z." Gather feedback on that. Do that for a few different things before we write a JEP, so that when it comes to the point where we write a JEP, we have a concrete idea of what it is we want to do and how we want to do it, so as to avoid misunderstandings and confusions in the ecosystem when it actually gets delivered.
There's a lot happening with serialization in Java, and I'm thinking about whether somehow you support for serializing to JSON or something like that, so we can stop using Jackson and JSON libraries.
Yeah, there's a lot to be said about serialization. So the question is, what about serialization? Are we ever going to get better serialization? And this is something that we've been working on quite, in quite some detail over the last 3, 4, 5 years. So it sort of started with a paper that I put together called Towards Better Serialization, which was not a JEP, but it was a formal write-up that is hosted on, I think, is it the Amber Docs or Valhalla Docs repository? I think it's on
It's in the Amber. If you go look at the OpenJDK project Amber page, it's linked from there.
Yeah. So and this sort of started out as not even a concrete let's do this, but an idea of well, first of all, like an explanation of here are all the things that are wrong with serialization, including some that you know and some that you might not realize.
Little side comment: Brian had this great rant.
It was an epic rant.
It was an epic rant, and he would give it verbally, and he finally wrote it down, and that's the beginning of this document.
and
this is wrong, and this is wrong. And by the way, if you didn't think it was bad enough, this is wrong too.
It's true. It's true. It was very therapeutic. So we collected this rant in a sort of more, publicly friendly form, along with a direction of here's how it could be better. And it actually has very little to do with the wire encoding, right? So you mentioned serializing to JSON, which is totally possible, but your choice of wire encoding is only a small part of the complex, tangled ball that existing Java serialization, is. And a lot of people say, why don't you just use, and they point to their favorite serialization library like, JSON or Avro or Thrift or whatever, but many of them commit the same sins that serialization does by capturing state, by breaking encapsulation and breaking into the fields of the object, by reconstructing objects, by creating empty objects and poking the fields in rather than going through the constructor. And so many of those alternatives are actually just as unsafe as serialization. They just have a friendlier API than object input stream, or they have a friendlier wire format like JSON, but they're still disasters. So, we set ourselves to, answering, is there a way to do this that isn't a disaster? And we have a pretty good story. It's what that involves part of the pattern matching work that's coming out of Project Amber. But it does require the class authors to do a little bit more work. So when you're designing your class, not only do you have to design your representation and your API and your relationship with other classes, but if you want to be serializable, I'll put it in quotes because we don't know what we're going to call this thing, but we definitely won't call it serialization. You also have to design what is your at-rest format. And you have to provide constructor and deconstruction pattern for the at-rest format. And it might be that your at-rest format is exactly the same as your internal representation, in which case the constructor is the one that you already wrote for everyone to use, which is convenient, but it might be different. Like all the classes today that override read object or read replace,
Write replace,
read resolve. I can't even remember the names. Would be a candidate for that. So there is a really nice story. There's a complete prototype available. There was a talk that Victor and I did at Devox this past November about the current state of things. So things are underway.
Too many. Sorry, are you asking if we will leave old serialization there?
Yeah. Well, why don't we just standardize on some other serialization library? Yeah. So the question was two parts. One was, it seems to me like nobody uses Java I/O serialization. Couldn't it just be removed? And the other is, there's so many great serialization libraries in the ecosystem. Why not just pick one of those and pull it into the JDK, right? Those are your questions?
Not pull it into JDK because they work so differently. Avro works very differently from SPE, for instance, or Blink or any of the others. So it's sort of more like let the, and I can't see how you in a nice way can pull them all in.
Okay, so just leave serialization out of the platform and leave that to the ecosystem. Okay. Yeah. Okay. So let me disabuse you of a few things, because these are very reasonable questions, but they rest on misassumptions. So it's really common in an ecosystem as big as Java to go from, well, I don't use X and none of my friends use X, to nobody uses X. And it seems kind of reasonable. You look around, using it. But the reality is, a lot of people still use Java IO serialization. So if we pulled it out, we would break a lot of applications, and we would break a lot of important applications. So that's not really an option. We have to give people a migration path, and there has to be a sort of gradual but easy way that they can take their existing serialization code and migrate it to something else. The other misconception is, well, we could just use Avro or pick one of the 30 or more serialization libraries out there. But the problem is, all of those rely on hooks that were put into the JDK to support serialization. So the assumption of, well, we would take Java IO object input stream out of the JDK, but we leave in all the hooks that have the evil embodied in them, that's ridiculous, right? So if we did that, all of those other libraries would start breaking too. And then the option of, well, just let people use Jackson or Avro or whatever is not really an option. So we have to give people something that that replaces the functionality that will be lost by tightening or removing the mechanisms that allow you to, for example, deserialize objects without calling their constructor. So that's what we're doing.
Yeah, I would add a sort of orthogonal answer to that, to the last question is providing a basic serialization mechanism that works, that is safe, and that everybody can use, and that's just in the JDK is important, right? In general, when we look at evolving the platform, we focus mostly on the things that can only be done in the platform, right? Lambdas could not have been added from outside, right? Modules could not have been added from outside. One could say that, oh, well, yeah, just, okay, use whatever serialization library you like. If we take the magic evil hooks out, then they will cope, they'll figure out conventions, and people will have to adhere to them, and just use it. But there's actually an argument that we shouldn't only do things we shouldn't limit ourselves to doing things in the platform that can only be done in the platform. It's important to have a good out-of-the-box experience for developers. There are certain basic things that almost every developer needs. A JSON API. Yeah, sorry, it's taken so long. We'll get there. I think the Java time package is an example of something that is not obviously something that has to be in the platform, but you pretty much need it, right? So we look at a good safe, secure serialization mechanism as another sort of batteries included kind of feature, that it should just be there.
I'm going to move away from serialization. I was listening to a great podcast with Ivan Bieler called Sandos, I think his name is. He was talking about the Valhalla project, which sounded completely amazing. And with all these new things like stack optimizations and operator overloading, all these things. My question to both of you is, let's say Project Valhalla becomes stable. What are the features that you two are most looking forward to building upon when the Valhalla project is actually in the game? That's because he was talking a lot about how Project Valhalla opens up so many possibilities.
Mm.
I'm wondering, what are the things that you are most loving about this one to build upon?
So the question is, what are you looking forward to when Project Valhalla arrives, besides actually shipping it, which I'm very much looking forward to, believe me. So I'll share a little bit about my personal motivation for helping Project Valhalla get started, and it grew out of the work that we did in Java 8 with streams. So, the original sin of Java, as it were, is the split between primitives and objects, and this in 1995 was a forced move. We couldn't do anything else, and it seemed pretty reasonable. Ints seemed pretty special. And so doing something special for ints seemed okay. But the problem is, if you have an architecture with a seam down the middle, when you try to build more layers on it, every layer has to deal with the seam of the previous layer. And so we saw this quite dramatically when we did Java 5, where there were significant compromises that had to be made in generics to deal with primitives. You can generify over everything except these 8 types. We had to complicate what is already one of the more complicated areas of the spec, which is overload resolution, to support the overload between int and integer. And so all of this accidental complexity got added in Java 5 because of this original sin. And then fast forward to Java 8, hold my beer, right? That we had this this explosion of hand specialized types like int stream and long stream, and the function types like int to long function. And when Valhalla comes, I'm looking forward to never doing that again. So it's not like, what will I be able to do that I couldn't before? It's like, what won't I have to do that I had to do before? That really motivates me on this.
I'm not sure I would give that much of a different answer. Although, so are type classes part of Valhalla?
So they're under the Valhalla umbrella, but they are, sequenced behind at least the 4 JEPs that have been talked about so
right.
far.
So I'm really looking forward to be able to write code with type classes, which are a bit of a subtle concept to explain in a minute. But basically, they're a way to abstract over classes rather than instances, which is essentially the abstraction that you get today. If you're familiar with Haskell, Haskell has type classes. And amongst other things, if we have type classes, we can do, I think, a good controlled job of operator overloading. So that if you want to use the plus sign to add complex numbers, you can do that. But we will definitely not. Don't worry, or at least sorry if you're disappointed. We will not go so far as languages like C++, for example, and define double greater than as system out println. That's not going to happen.
And if has anybody here read or watched the video of Guy Steele's paper from was it 2000?
Early 2000, yeah.
Yeah, it was about 2008, right. Called Growing a Language. So, absolutely fantastic paper. Write it down on your phones. Go search for it tonight. The video is a little old, but it's
the video is very good too.
It starts out weird, and you're wondering, okay, what's going on here? And then eventually you figure it out, and it's masterful. But there is a lot in that paper about our approach for extending the language in a way that we can add new numeric types like float 16 or complex or decimal in a way that doesn't make them look nailed on the side. And so that's one of the things that we intend to work on after we finish the small amount of work we have left on Project Valhalla.
Standing way in the back.
Yeah, so the question is, in the stream API, is it possible to iterate over an ordered stream? Not all streams have a defined encounter order, but to iterate over an ordered stream in such a way that you get the index and you get the element. And the answer to this is a little bit unsatisfying, probably, which is So that's essentially a zip operation. And it's an operation that parallelizes very poorly. So the philosophy that we took in the, at least in the initial version of the streams library, was we wanted the choice of execution strategy, sequential versus parallel, to be independent of the semantics of the operations. And operations for which there was no reasonable parallel implementation were scrutinized very carefully, and that's one of the reasons why you didn't get zip and why you didn't get this operation. It's possible we may reconsider that in the future, and if you look at the work that was done on streams recently, which is adding the gatherer abstraction, it is a lot easier to write that yourself with gather. And if you don't need a parallel version, you don't have to write one. Gatherers support both sequential and parallel operations, and you decide what you're doing. So it's something that is easier for you to do yourself now than it was, when we originally did streams. But that's the reason. Sequentially, yes, yeah. So in records, were we ever tempted to support default values so that for individual default values for individual components? Yeah. So the question is, were we ever tempted to support default values for individual parameters so that if you have a record with, say, 7 components and you only specify 2 or 3 of them, it can figure out the rest of them, right? That's a question? So we were never tempted to do that for records because I think that would be a very unsatisfying outcome, which is, why can I only do it for records and not for constructors? And it would have created another significant impediment to refactoring between records and classes. And one of our models for records, because it was very successful, was enums. So enums and records have a lot in common. And one of the things that I really like about enums is sometimes you'll have an enum that has gotten so complicated that it can no longer be an enum. And then you have to hand translate it to a class that looks a little bit like an enum with static fields for the enumerated constants and such. And you can do that. And you can do it in a binary and source compatible way. And we did not want to put features into records that were strictly tied to records and you couldn't use them in classes, and for which you had no chance of that ever being the case, because then anybody who used those features would be stuck and wouldn't be able to migrate. So to answer the question you haven't asked, are we ever going to get that for classes? And one of the most common requests that we get is for nominal invocation of constructors. So rather than just specifying the arguments in order, you specify A colon this, B colon that. And everyone asks for that. And what they really mean when they ask for that is not just, I want nominal invocation, but I want nominal invocation plus optional values. And we hear that. It's not an easy feature to deliver, so we don't have a quick answer for it. But we understand that it has a lot of value. In particular, it makes about 90% of the builders go away. And that would be really nice. I'd love for those, low-value boilerplatey classes to go away. So we'd like to do that. We don't have an answer for it yet, but it's on the radar. So I think your question is, wouldn't it be nice if there were some declarative way to attach a invariant to, say, record components, where you say record R int x where x greater than 0 or something like that. And then I wouldn't have to write that in a constructor, because writing a constructor for a record like triples the length of the record because it went from one line to, you know. Yes. Yeah. So our thinking there was we certainly don't want to make it overly difficult to validate parameters because we don't want people to use that as an excuse to be lazy and not validate their arguments. And so records have a compact constructor form that doesn't make you repeat the argument names. And what's inside the body is, doesn't have to do the tedious this dot x equals x, this dot y equals y. It just has to either reject bad parameters or potentially transform them to good values. And so that was the compromise that we took. We did explore various, declarative mechanisms where you could attach expressions either to parameters or to the record header. And we found that A, it got out of hand really quickly, and B, you often got to a point where you couldn't express these as purely as expressions. You needed some statements. And so you were falling off to writing a constructor anyway. So it was an attractive idea that works nicely in the toy examples and falls apart in the real world examples. So we didn't go that way. Yeah. So the question is, are we ever going to use the const keyword? And what are our grand secret plans that we haven't told anybody yet, but that will tell you if you just ask us at a conference? Right? That's your question? We don't know. We have no clue. It's been reserved since day one.
Yep.
And we haven't used it yet. Yeah.
Sorry, what? Can you repeat that? Are you asking will we ever remove the deprecated classes? No. So as you might know, we evolved deprecation. Well, but let's go back and tell more of a story. Back in the day, JDK 1.1. George will remember this because he was working. George used to be an engineer. Then he went to the dark side. So the original AWT, the Abstract Windowing Toolkit, was, shall we say, poorly designed.
Hastily written.
Hastily written in Java 1.0. And as the swing team was getting going and thinking about doing a proper modern UI, well, modern at the time UI toolkit that would be based on AWT, they realized, well, it's got all these flaws. We need to evolve AWT. This thinking begat what came to be known as the Great Deprecation. So many perfectly good methods in AWT were deprecated and replaced by methods that did exactly the same thing. And this was because it was important to adopt new and more consistent naming patterns, partly for swing and partly for use in visual builder tools that were all the rage at the time. So to this day, if you look at the AWT API, you will see lots of deprecated methods, and if you go look at the source code, it's like, the method, get size the method getWidth just turns around and invokes the method called width and returns that value. So the deprecation mechanism we had in the Java compiler was very primitive at the time. You could deprecate something or not, and if you deprecated something and somebody used it, they would get a compiler warning at compile time. It was a fairly crude tool. So when we deprecated all this stuff in AWT, people got pissed off. Because I've got this perfectly good application, and you're telling me I can't use these methods, but I look at the source code, and it's just doing the exact same thing. So what's up? What's up, you morons at Sun? Stop doing this to us. In reaction to that, we didn't deprecate anything for a long time. We had other priorities besides, coming up with a better way to deprecate things. But eventually, history caught up with us, and round about, I forget whether it was 7 or 8. Stuart Marks on our team spent a good long time thinking deeply about what does it mean to deprecate something. What are all the various ways that you might want to do it? What ways actually make sense? He looked at other platforms, in particular the Solaris operating system had a very rich and complex way of tracking the status of programming interfaces and evolving them. We didn't do that, but we drew some inspiration from it. What we wound up with in Stuart's design was you can deprecate something, and that deprecation just means, hey, this is not the best thing to use. So, yeah, maybe don't use this. Use this other thing over here. It's better. And for that kind of deprecation, it's easy to suppress the compiler warning. And in those cases, will we ever take the deprecated thing away? Maybe, but probably not. The other way you can deprecate now is you can deprecate for removal. The deprecation annotation takes a Boolean parameter. If you say for removal equals true, then that's a signal that, hey, you developer, you're using this, it's gonna go away. It's not. It might not be going away real soon. Here's what you should do instead, but it will go away. And starting in JDK 9, when we introduced modules and modularized the entire platform, in JDK 9 and in preparation in JDK 8 for modules, we did deprecate things and we did remove them. In particular, some things that would have made it impossible to come up with a sensible set of modules. We also have deprecated and removed a few other things. Java EE. Everybody remember Java EE? All that stuff, whoosh, is gone. It's now separate as it should have been. The EE components that used to be in the SE platform, they're now called Jakarta, whatever. Yeah, so modern deprecation, if something is deprecated for removal, then that's a sign of serious intent. Please take it seriously. Please, change your code at the earliest convenience not to use that. But if you're just getting a deprecation warning and it's not for removal, it's fine. We will probably never remove those things. And if we were going to remove those things, we would flip the for removal bit first, and you would have several releases in which to change your code. It's like a null pointer, I guess. You could, yeah. Eventually, your code will blow up, but unlike with null pointers, you will have had plenty of warning.
Well, and I'll just add that this is a question that comes up a lot, and the existence of deprecated stuff seems to really, really bother some developers. Yeah. And so it feels like this you're working in a messy workshop and you should be ashamed of yourselves. You should clean it up, kind of feeling. And, the reality is it's a lot like what I said, to the other questioner who said, but nobody uses serialization. It's like, well, nobody uses serialization. And similarly with methods that are deprecated, there is still code that would break if we took it away. And so we have to weigh the, temporary feeling of having cleaned up our workshop that we would get from taking it away against the genuine anger we would get from large paying customers, if we broke their code. And it's usually not worth it. And so we reserve removal for something where this thing has to go because it's fundamentally broken. It's either unsafe or it can't be implemented correctly, or it is an impediment to doing something else important in the platform, where we're willing to say, yes, the code that depends on this has to change, but we do that very carefully.
We do that very carefully, and when we do it, for example, we do corpus searches over like Maven Central to see, is there code out there that's using this? And if the answer comes back that, oh, it's like that much, then okay. But if the answer comes back, well, then we think a lot harder about it.
Yeah, when Mark talks about corpus searches, this is something that we do a lot. We built tooling that goes and scrapes all the Java code we can find from GitHub and Maven Central and wherever else we can find it, and we throw it in a big repository, and then we can build an instrumented compiler and run it over that corpus, shard it over a lot of cloud nodes, and answer questions like, how often do people really do this? Rather than guessing whether nobody does this or not. And we get reports of, out of this many 100 million source files, we found 63 instances of this, and here they are. And then we can actually look at it and say, all right, of those few instances that were found, how easy would it be to change them? And that feeds deeply into our decision processes.
Yeah, but eventually we're going to just train a large language model on that corpus, and that will design all the future features, and Brian and I can retire.
Yeah.
Somebody who hasn't asked a question yet, way in the back. Sorry, I didn't. What?
How do we kill Lombok?
No, it's a feature. It's not a bug. It's a feature. Sorry. So there was a question in there somewhere. There were comments about Java needs a precompiler, and there was a question about killing Lombok. Well, records
Took a big bite out of Lombok.
definitely put one knife in. Well, it is not within our power to deprecate Lombok.
We can denigrate Lombok, but
which we do on a regular
basis.
basis.
We do all the time. Yeah. So the question is, isn't there something you can do to kill Lombok? And we're not violent people. We don't want to kill anything. But if certain things just disappeared, it wouldn't bother us. And so our goal in some of these language features is to remove the perceived need for developers to have to reach for these tools. And so in the case of Lombok, records are a piece of that story. And I think it did it did have an effect. We may do more, but that's a matter of priority. I mean, mostly we care about is there anything we can do for Java developers so that they don't feel like they're in such pain that they have to go and use something as horrible as Lombok, which we don't want to kill. We just wish it would disappear. Lots of questions now.
Wow, only 10 minutes left.
Yeah.
That motivated. So you?
That what provides? Unsafe.
Oh.
Ah, yes.
Oh, so that's actually work in progress. So the question is there a need, and are we trying to fulfill it to help people not use the Unsafe API anymore? Yes. So this has been a long-term plan. We started thinking about probably in 2005, and it got intertwined with the introduction of modules. So if you've heard the phrase, our colleague Ron Pressler has come up with this great phrase, integrity by default. The platform should have integrity by default. Modules were a big down payment on that. There's more work to do. Over time, we formulated this plan when we did modules in 9. We want to make the platform safe by default. A library, a random library that you that you incorporated into your application that you might not even know you have because it's a dependency of a dependency of a dependency, you should not be able to crash your application because it uses unsafe. Right? If you as the application owner want to enable a library to use unsafe, you can do that. So we're gradually making it harder and harder to use unsafe. We will still leave it up to the application developer to be able to do that. In parallel, over time, we have been designing replacements for unsafe. We've been designing features that act in part as replacements for unsafe. A big part of that was the foreign function of memory API that was finalized in Java 23. That's a big leap forward. It's way better than JNI. It lets you deal with native code and native functions outside of the Java universe in a safe way, and it removes the need for much of unsafe. So I forget was this in 24, if it's going into 25, so many features and so many releases I can't keep track of them. We are deprecating for removal a bunch of the stuff that's still an unsafe. So the undeprecated part of it is shrinking and shrinking and shrinking. Eventually we will remove it because there will be viable replacement APIs that are a proper part of the platform.
I have a slight correction to the thing I said before about not wanting to kill anything. We really do want to kill unsafe.
Unsafe is deeply evil. Yeah, unsafe and the other thing, another very small thing we've desperately been trying to get rid of, and this feeds back into the integrity by default story, is the set accessible method in the reflection API, which allows any random code to say, hey, that class over there, I want to be able to mutate final fields in its instances, and that is just horrible. It makes it harder to reason about your code. It makes it impossible for the hotspot virtual machine to do optimizations that it's perfectly capable of doing, but since it can't trust final fields, it's not going to do, because that would probably break somebody's code.
And where did we get set accessible?
Guess. Who would like to guess? What feature going into the platform required set accessible in the reflection API?
There's steam coming out of my ears. That's a hint.
Starts with an S. Spingo. Serialization. So, how are we doing at time? A couple more minutes.
Yep.
Well played.
Yes, that's excellent. So the question is there going to be another edition of Java concurrency?
I was just scratching my head thinking, 2006, what's 2006?
And it is amazing it's been 20 years. So sort of in each of the last, let's say 10 years, I ask myself, is there more leverage in producing another edition of the book or in making more Java? And every year making more Java seems more appealing. So I think for the foreseeable future, I'm going to focus on this.
It's a good book.
Thank you.
You talked about the things that are start to bleed when you want to do something like unsafe, serializable, and I took this from your talk in Belgium, where you said it has to go because it's peak complexity, it's basically just in our way. Is there anything else that's in our way you haven't talked about yet? Just curiosity, what else has to go besides unsafe
And set accessible. So the question is, what else in our view has to go that is just so toxic it has to die in a fire?
So certainly I have a hard time thinking of anything that that I can muster up that level of hatred for as the two things you mentioned.
Brian is not a violent man, really.
But there are always things that we would like to fix. There are always things that are impediments to evolving the platform. And, for each of them, there's a trade-off to be made of if we make this change, it's going to impact certain people's code, but it's going to make everyone else's code better. And we're constantly evaluating that trade-off.
And then there are things that we know are just really bad, but we will never change. I mean, covariant arrays. Well, it's too late.
We're going to make those worse.
You're going to make those worse. Well, I think technically we're over time. One more question?
One question.
Okay, one more question.
From someone who,
someone who
hasn't had a
has
chance.
not asked a question yet.
Yeah, you raised your hand a few times.
If we told you, he would fire us. Yes.
Not enough.
Not enough.
You should come work for us. We're hiring.
Yep.
But we are hiring.
We are hiring. Yep. And it's a great place to work. All right. I think that's a good place to stop. Okay.
Thank you.
Thank you, everyone.